I'm Satyam, and we are here to tell you about one of the amazing tools of cyber forensics, that is Helix version 3.
We talk about the term digital forensics or computer forensics or cyber forensics, it more or less means the same thing. So we could define it that cyber forensics is the science of collecting, examining, analyzing, and reporting electronic evidence. This brings us to the first question: where do we find this electronic evidence? We could find it in a hard disk in maybe deleted files. Now, what we really mean by deleted files is that when a file is deleted, it is typically not crashed from the media. Instead, the information in the directory's data structure that points to the location of the file is marked as deleted. This means that the file is still stored on the media but is no longer enumerated by the operating system. So the operating system considers this to be free space and can overwrite any portion of the deleted files at any time. Then we have slack space. All file systems use file allocation units to store files. Even if a file requires less space than the file allocation unit size, an entire file allocation unit is still reserved for the file. For example, if the file allocation unit size is 32 KB and a file is only 7 KB, the entire 32 KB is still allocated to the file, but only 7 KB is used, resulting in 25 KB of unused space. This unused space is referred to as file slack space, and it may hold residual data such as portions of deleted files. Another term that we come across is free space. Let's see what we really mean by this. Free space is the area on the media that is not allocated to any partition. It includes unallocated clusters or blocks. This often includes the space on the media where files or even entire volumes may have resided at one point in the past but have since been deleted. The free space may still contain pieces of data or evidence. How do we really handle this kind of evidence? We could do something called a logical backup. A logical backup copies the directories and files of a logical volume. It does not capture any other data that may be present on the media, such as deleted files, residual data stored in slack space. We have a much better alternative that we could use, and that's called as a bit stream imaging. Bitstream imaging generates a bit-for-bit copy of the original media, including free space and slack space. Bitstream images require more storage space and take longer to perform than logical backup. Another important source of digital or electronic evidence could be a cell phone, where you have information in the SIM card, phone memory, memory card, as well as even information which is stored inside pictures in a sort of like what the GPS information would be, and we have called detailed records. I would like to discuss a couple of interesting cases I have heard about in the past. In one particular case, investigators were given a cell phone. I think it was a BlackBerry, and they were able to even recover the details of a missed call made to that particular phone almost 3 years ago. Nowadays, when you take a picture using your smartphone, usually by default, this GPS location is embedded into that image. That means the latitude, longitude, and in some cases, even the altitude of where exactly that picture was taken. We have got a couple of unfortunate incidents in the past. In one case, a young boy, I think he was in the 10th standard, his dad gifted him a very expensive game for his birthday. So this kid naturally clicked the photograph, put it on his Facebook page to tell his friends about this lovely gift that he received. Now, unknown to this boy, there were a few adults actually who were part of his Facebook friend list which he didn't know about. One of them was a thief. So, when he saw this pic, he realized that this boy has a lot of money at home. From the GPS information in that pic, he got to know the exact location where this boy was staying, and one night he broke into their house to steal a lot of stuffs. Unfortunately, he even ends up stabbing the boy's father in the bargain. This is why we have got to be very careful and ensure that in our cell phones we keep the GPS location switched off in our photographs. Call detail records are used in a lot of cases nowadays, usually for conventional crimes such as chain snatching, sometimes even murder related cases, housebreaking, and robberies. In cell phone forensic, we usually deal with iOS, BlackBerry, Android, and Windows Mobile. iPod could also be a source of electronic evidence. There was a very interesting case investigators solved a few years ago where there was this company which was doing a lot of confidential projects for the government, and naturally, every employee who would work on that project was thoroughly checked before he was allowed to enter the office. There was this one young lady who would show up every day with her iPod blaring music playing on that for the security guard to thoroughly check her to make sure she wasn't carrying any data storage device inside. But the security guard hasn't been trained that even an iPod is a large data storage device. So, what she would do is, once she would be in the office, she would connect her iPod to the computer, dump some of the confidential information on it, then delete those files. Once she would reach home, she would undelete those files using a forensic software, and that's how she was siphoning out a lot of confidential information. Like I mentioned, iPod, even a USB drive naturally would be a big source of electronic information. Then, of course, we have digital cameras. In one particular interesting case, there was this lady who gave investigators a digital camera and asked them to recover all the deleted photographs from them. When they recovered those photographs, it showed evidence that her husband was actually having an affair with someone, and on a particular secret vacation he had taken with that woman, they clicked a lots of photographs, then they had deleted them from the camera memory. Well, they didn't really realize it that could be recovered so easily, and this information was presented to the court during her divorce proceeding. Other source of electronic information could be CD, DVDs. You will be surprised to know that even floppy disks are still being in a lot of industries, and they pop up in a lot of cases that I investigate. And of course, we have computer networks, Wi-Fi networks, and even the internet, which can be the huge source of electronic information. There are some very interesting cases where someone does a war driving, as a result of which he gets a huge list of open Wi-Fi networks and then use package sniffing to actually sniff out a lot of confidential information. Digital evidence can also be hidden in pictures using steganography, encrypted files, password protected files, formatted hard disks, deleted emails, chat transcripts. In fact, it's not just electronic evidence. In many cases, we also come across physical evidence. For example, if you want to prove that a particular computer is being used by a particular person, you could look at the keyboard that may actually have a small quantities of dead skin from his fingers, maybe a hair or two fallen on it. And conventional forensic could prove and match a particular computer to a particular suspect. Let's just take a look on the next video by Smithsonian Channel and understand more about what actually cyber forensics is.
Cyber forensics involves the recovery and investigation of evidence from any digital device used to commit a crime. At its most basic, it's old-fashioned sleuthing, following a trail of digital footprints through a single fixed device, like a hard drive in a lone computer, or to the furthest reaches of the internet. In the 21st century, we leave these electronic traces everywhere. Through system logins, web page visits, Twitter feeds, smartphone GPS applications, and more. Whatever someone does online, they leave behind digital footprints that can reveal who they are, what they did, and when they did it. In the future, investigators will employ the powers of machine learning.
We will come to rely more and more on artificial intelligence, machine-assisted review of documents and of data.
These intelligent machines will scour data evidence in volumes no human being could match. But for some, this technology raises the fear of privacy invasion by Big Brother.
Digital forensics must be used to uncover the truth and also, hopefully, to protect your privacy, which is another battlefield that we will all find ourselves playing on in the not-too-distant future.
As we live more and more of our lives online, cyber forensics becomes more critical than ever to keep us safe.
Hi guys, I am Manas and I'll be explaining you about Helix 3, which is an open source tool for cyber forensics. So what is Helix 3? Helix 3 is a live CD based on Linux that was built to be used in incident response, computer forensics, and e-discovery scenarios. It is packed with a bunch of open source tools ranging from hex editors to data carving software to password cracking utilities and more. So note that the Helix 3 version you need is 2009 R1. This version was the last free version available before Helix 3 was taken over by a commercial vendor. Helix 3 2009 R1 is still valid today and makes for a useful addition to your digital forensics toolkit. So I'll show you how to download Helix 3. Open your browser and type Helix 3 forensics tool. You gotta hit the eFence link because Helix 3 is an eFence product. Um, it will take some time. My internet is very slow. Yeah, so you have to hit this link if you're looking for free original Helix 2009 R1. You need Helix 3. Download it. Yeah, so here you have to fill in your details like your email. Company is not mandatory, so we'll continue to download. Hit the download link. Save file, yes. So it'll take a long time. You can see 39 minutes here. I have already downloaded the tool, so I'll show you how to use it. Okay, so run the application. Effectively, it allows you to take an ISO or CD worth of tools placed in your acquiring or suspect machine and acquires a forensic image and some basic system information. On the main dashboard of the suspect machine, once Helix is loaded, this is where you can preview system information, acquire a live image and various incident tool. Now the system information window will give you a basic system information, that is the operating system, the owner name, the organization where the owner logged in as an admin or where they have admin rights, the network information, host name, username, IP address, the NIC card, MAC address. And if the system is logged into a domain arena, it's also going to tell you what drive lettering has been assigned. You believe or not, its file type and its size. Okay, on the second page of system information tab, you're gonna see the running processes. This comes in great use because we know as the investigator what processes are running on this computer without opening the task manager or any other application. We can go through and see what's in there. In the acquisition window, it has got a stability to capture in image directly above the physical memory of this system. In this case, it has got 7885, so we can only imagine what would be stored in our clipboard. Here we can choose our location. We can set up our destination to actually punch out our DDOR raw image across the network or locally across the network to say an external if we have an external hard drive plugged in. Here we can name the image, and I think in this case we are gonna go ahead and change the image, change it to video underscore sample. Now we will save it as a DD because we are using FTK imager, so DD, the raw images, are always best to use. Okay, the block size, you can leave this for now unless you want to specify a different block size. We will get into that later in the advanced video. The error reporting will skip over errors if you run into one or we report them inside the log, but the split imager options, let's just make two images in case our destination media is too large. On the next page, you're gonna see some information about access data. The link will be there in the video notes, so don't worry about that. You would be able to get the imager and the FTK just as the demo versions. The imager is free. Now after this, since we have got some basic information, we are going to go into the incident response section, and in the incident response section we get a very wide range of tools that will come in very useful. Windows Forensics tool chest, first responder utility, the incident response collection report, and agile risk management. On the next screen, on page 2, you're going to actually see what is by far one of the simplest interfaces for file hashing. The command shell, PuTTY, file recovery, rootkit revealer, and we can use screen capture where we can take pictures and things while user is using it. We're gonna go and hash a file, and it works just like MD5 sum in Linux and any other operating system. But it generates your file, so we can say this is pre-seen, this is what the original hash for this file was. And putty SSH, VNC server, in this case, we just wanna put the disk in and go somewhere else and do all this remotely. PC on and off time, let's just know the last time this PC was booted up. On page 3, we get the PST password viewer, the mail password viewer, network password viewer, messenger. We get all these password viewers, and we can go through it and browse the internet exploit history. We can look at the Mozilla Firefox cookie viewer, registry viewer, USB preview. Now, effectively, it lets us know what this is. Usually, we can glean an in-depth profile where you have visited, what passwords you were using, what USB devices were in there, and so on. The file browser button is just your basic file browser. It allows us to go through and see what files are in which directory. On my laptop, there is only C directory. That's what you're looking on the screen. We can look to subdirectories, but I think the best feature is the fact that at the bottom here you click on this little checkbox for calculating MD hash on files. It automatically generates hash in each time. There is also a picture scanner. We can go through, we can select where we want to go for the pictures, and let's try the Helix folder. Just be patient. Usually it takes just a minute. There you go. But I usually skip over that. Now, our favorite part of this test is the fact that if you would reboot the suspect machine, it's gonna take you into the Helix's live session. Now, the live session for the Helix disk is an Ubuntu 8.04 variant that effectively lets us run a live complete operating system in our section. Again, I'm running a virtual machine, so it's gonna be a little different. It's gonna boot up and it'll tell you what it is doing. So it might take some time. You can see it is loading all the essential drivers. It is running scripts, and it is moving mount points, setting up console keyboard, setting up locals. It'll configure networking, yeah, pre-configuring networking and other modules. But finally, once you get in there, for those of us who are Ubuntu users, they are going to notice a very familiar interface with a few extra tweaks from eFence. Now the next part will be taken over by Satyam Chata.
Okay, we are in Helix 3, the beta version of it. And if you have used Helix before, it's actually got a very nice desktop to it. It's got a lot of cool tools on it. Let's take a look at a few of these tools and see what they do. Now, Helix basically, as we said, is primarily geared towards instant response and computer forensics electronic discovery. So we have got a lot of really good tools out there that have been used separately from Helix for a while, but they are all compiled and put in one place on Helix distribution. So you basically have one-stop shopping. Now, these tools basically are open source for the most part. There are some tools in here that may have little proprietary code in there, but they are pretty much open source as far as we care, as far as we are concerned, so that we are able to use these tools. Helix has a plot for different tools built into it, but in particular, we want to look at the forensics and the incident response tools. And as we have said, there's got a lot of tools in there that you can get and download separately, but Helix is very convenient in that you get a lot of tools in one place. So let's go to the forensics and incident response section. You got tools like Adepto, which is very good at imaging drives. You got Autopsy, which is a tried and true forensic tool that's used for forensic analysis. We have also got Hex Editor, file browsers, just different tools that you can do different things with. You have got password cracker, that is OPH crack. We have even got Wireshark, the most popular network sniffer out there. Since you have got a lot of these tools, but you also got different Linux tools as well out there that come with the normal distribution. Again, like Backtrack is not intended to be an entertainment PC, but it is intended to do the job and give you some utilities that you can use to help you do forensics work with. See, you got different file viewers as well, image viewers, and so forth. But you have also got some typical things such as web browser, a remote desktop viewer, and even office type softwares. So you have got some different tools that you can use to perform forensics analysis with to securely gather evidence without affecting the target hard drive, without writing it to it also. So Helix is a very good distribution. Now, Evans has changed their business models somewhat concerning Helix. Previously, Helix was free to download, free to use, and recently, with the advent of version 3, it's available on a membership basis. You actually have to become a member of the Evans forensic community, and for a nominal fee, you can still use Helix free and get very good support and updated tools so forth. But the older versions are still out there for you to download on the web as well. They are still very good. They contain a lot of the same very good quality tools that Helix 3 does. In this video, I will be telling you about Adapto tool, which is a tool for digital forensics. So, I have connected two USB drives here, one 8 GB empty pen drive and the other 256 MB with two PDF files. I plan to clone the 256 MB USB drive on the 8 GB USB drive. So this is the Helix desktop. The mouse scrolls over the basic menu sections, and in the forensics and incident response section we have got Adapto, Autopsy, and many other tools. So let's go and check out the section of Adapto. This is our basic area of interest. And before that, we just go and mount our devices, that is the pen drive, 8 GB pen drive and 256 MB drives. So you should check that tick mark should be there on both the drives after mounting it. And then we will go forward and proceed with the tool. Here we enter our name. There will be a unique case number assigned to this software, then enter. First we will check our both drives whether they are mounted or not. After mounting both, we will need to click on the rescan device link so that the machine can discover them. And now we select one of the USB drives. I have selected here my 256 MB. Here we can leave a comment. I will write just this is a test file. Now here we have to choose the mount point. So I selected my pen drive where I want to mount my file of 256 MB. Then I selected MD5 and then I will click on start and wait for automatic stop. Yeah, here it is stopped. Now I will check the log files which says successful. Now we will go to the restore or clone section. In this again we will rescan the devices, selecting the source and destination drives. I have selected the source drive as 256 MB drive and destination after rescanning we will get it to our pen drive, that is SGC1. Now I click on clone. It will take some time to clone. By that time we will keep checking the logs. It will give a message that clone is complete and successful after the cloning process is done. Wait for some time. Till then, just check out the tools, whatever we have on Helix. Some of the extra ifs tweet and modify your screen preview by that time. This is the chain of custody form. The report can be made to generate from here by clicking the Create PDF button. Now we can again check the log section so that we will know if the cloning has been completed or not. So here is the log section. So now, yeah, the cloning is completed as you can see from the commands here. Device cloning is started earlier and then command completed, verify successful, the hash matches and attend the command got complete. So after this, we have to check whether what actually has happened to our pen drive. So you can dismount the USB drives now and check what has happened in the base machine. And we can also check it in here in this Helix terminal with the terminal bar. So here we see that our pen drive has been changed to 256 MB by name and also both store the same documents. Again we will mount and check in the terminal section whether our 256 MB drive matter has been cloned to our pen drive or not. So when we mount both, this time I will get both the names as 256 MB. You can see on your left hand side of the screen. So on terminal, just follow these steps, the commands, whatever I am writing, and you will see which file has been copied. Remember that your source directory is the 256 MB drive and destination is your pen drive 8 GB. So here we got the file which has been cloned. So that's about the adapter tool. Apart from that, we have other tools also like Autopsy, Hex Editor, Wireshark, which will help us to check what all kind of file formats are passing when a user requests the server. Also, we have XFprot and various kinds of virus scanners, password cracker, and other things. So that's Helix in a nutshell, and it's a very good product to be used for security and a very good live Linux security distribution. Whereas the focus in other security distributions might be penetration testing or security testing, the focus on Helix 3 is incident response and computer forensics.
Hi guys, thanks for watching our video. If it was useful, then please hit the like button, and we would like to know about your feedback. Please type that in the comment section. Thank you.